is -2, which means your amplitude's 2. The B is 4, which means the period's 2 pi over 4, which is pi over 2. There's no phase shift. There's a vertical shift up 1. So then I'm going to find the key points. I do 0, and then I do pi over 2 times a fourth, so pi over 8, pi over 4, 3 pi over 8, and then 2 pi's, or pi over 2 is the last one. So I'm going to put it on the x-axis. I get 0, pi over 8, pi over 4, 3 pi over 8, ladies, shh, pi over 2, amplitude's 2. It's a negative sign, so where does it start? Where's sign start? X-axis or amplitude? Sign normally goes here, 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 but because it's a -2, it switches. It goes here, 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 here. So the sine curve looks like that. This only gets you 3 asymptotes though. Here, here, and here. So you have to add on. You can either go this way or you can go this way, but it needs to get 1 more asymptote. Then we shift everything up 1 because of the +1. So now my curve goes from here to here. And then the parabolas bounce off of that.
And for that one, why do you add the...
All right, number 4. So my A is 1, which is my amplitude. My B is 1, so the period is 2 pi over 1, which is 2 pi. This time there's a phase shift, so I'm going to take this, set it equal to 0, and I get my phase shift is pi over 2. So everything's going to the right, pi over 2. No vertical shift. Take your, God bless you, take your period, multiply it times a fourth, times 3 halves and 3/4, and you get your standard 5 key points. And then we're going to add pi over 2 to each of them. So I get pi over 2 plus pi over 2 is pi. This would be 2 pi over 2 plus pi over 2, so 3 pi over 2. 4 pi over 2, which is 2 pi. And this becomes 4 pi, no, sorry. This becomes 4 pi over 2, so 5 pi over 2. And those are your key points. So they're going on the x-axis. Pi over 2 is the first one, then pi, 3 pi over 2, 2 pi, 5 pi over 2. Amplitude's 1 and it's cosine. So I start at the amplitude, down, down, up, up. My curve would be this so far, which only gets you 2 asymptotes. So we're going to drop it down on either side to get your additional asymptotes. And then comes the parabolas. So as a reminder on the test, you're getting either secant or cosecant. You're getting the other one's reciprocal. So you'll end up having to graph one sine, one cosine. One of them will be its reciprocal. And then one tangent or cotangent. So there's 3 of these graphs, and they're like double points almost because these take a lot of work. Okay. They also take time, and if you're not practicing them, you're gonna get hung up on these, and then you're gonna be stressed for the time on the rest of the test. So the biggest piece of advice I could get you is make sure you're really confident in the step-by-step on these graphs so that you can do it swiftly. We started the inverse functions, okay? These are our negative ones. So these are our negative ones. So sine -1, cosine -1, tan -1, or arc sine, arc, cosine, arc, tangent. They would all mean the same thing. And yesterday we said that we have to restrict. We can't use our normal unit circle to answer these questions. So when we get to sine, we're looking for where the y is the value that they give you. So if it said arc sine or it said sine -1 of a value, you're saying where is the y, that value. But we said that we have to restrict sine from negative pi over 2 to positive pi over 2, which is the right-hand side of our unit circle with our adjusted angles in the 4th quadrant. Yesterday, and we took the unit circle, we edited it so that the right-hand side just showed the negative angles. So I'm going to do this again in a little bit. But so the right-hand side was the negative angles here to the pi over 2. And we said that that is the range we use to answer sine. We worked through the examples, and then we went to cosine. And we said cosine, we also have to restrict so that it would pass your horizontal line test, but we restrict cosine differently. With cosine, we go from 0 to pi. So on our unit circle, we use the natural top part of our unit circle. We would use those angles. So if I'm answering a negative cosine, it has to come from quadrant 2, whereas if I'm answering a negative sine, it has to come from quadrant 4 and the negative name of those angles. We worked through this example and we left off with tangent. So tangent, and if you think about it, the tangent graph looks completely different than your sine and cosine graph, right? For tangent, we use 1 period of tangent, and we restrict it the same as sine. We go from negative pi over 2 to positive pi over 2. So the answers that would be answers available for sine are the same for tangent. The only difference is that you can include negative pi over 2 and positive pi over 2 for tangent, because tangent is undefined at those spots. So cosine at those values, sine at those values would be negative 1 and positive 1. Tangent would be undefined. So I'm going to start to fill in this unit circle so that we can learn how to, so I'm going to recommend that you learn how to do this so that you could do this for Monday. Remember, I'm going to give you a blank unit circle Monday. I'll give you like 5 minutes to fill in whatever of you want from your brain, not from like your resources, but from your brain. And then I'll give it back to you on Tuesday to utilize for your test. So I would fill in the original radian measures. So it would be 0. This is, let me make that thinner. This is pi over 6. This is pi over 4. This is pi over 3. This is pi over 2. This would be 1, in that second quadrant, it's 1 less your numerator. So it's 2 pi over 3, 3 pi over 4, and 5 pi over 6. And then I would do in the fourth quadrant, you can keep going all the way around, 7 pi over 6, 5 pi over 4, and 4 pi over 3. And then in the fourth quadrant, my natural angles are 1 less than double. So this is 5 pi over 3, this is 7 pi over 4, and this is 11 pi over 6. You can also, instead of filling those in, you can leave yourself your little notes of like 1 less, 1 more, and 1 less than double if you don't have time to fill them all in. But then I would obviously add in the negative angles in that fourth quadrant because that's going to help you when you get to the inverse questions. So this is negative pi over 6. This is negative pi over 4. This is negative pi over 3. This was 3 pi over 4 if it's in the original one. 3 pi over 2. And negative would be negative pi over 2. And then I would leave a little marker for myself to remember that this is what I'm going to use for sine, negative 1. And the top is what I'm going to use for cosine, negative 1. And now I'm going to add that sine and tangent. Use the same side. So this would be for sine and also for tangent. Okay, then I would add in the coordinate points and the tangent. So I don't think you need to do it on all of it, but if you wanted to, do it on all of it. Instead, if it was me, I would just make sure I knew every over 6, every over 4, every over 3. Okay, but if you want to write it in all of it, every over 6 is a root 3 over 2 and 1/2. So this is root 3 over 2, 1/2. This is negative root 3 over 2, 1/2. Negative root 3 over 2, negative 1/2. And positive root 3 over 2, negative 1/2. Every over 4 is root 2 over 2. So root 2 over 2, root 2 over 2, negative root 2 over 2, and root 2 over 2. Both are negative here. Positive x, negative y. And then your over 3s. Your over 3s are 1/2 root 3 over 2. Negative 1/2 here, positive root 3 over 2. Both are negative here. Positive 1/2, negative root 3 over 2. At the top is 0, 1. On the right is 1, 0. On the left, negative 1, 0. And the bottom, 0, negative 1. And then the last thing I would add on are your tangents. And again, you could just know what they are for one set of angles, or you could put it all the way around. Tangent is 0 on the right and the left. It's undefined at the top and the bottom. It's root 3 over 3 for every over 6. I'm going to come back and add the sign on. It's 1 for every over 4, and it's root 3 for every over 3. All right, so we left off with the tangents. I added the values of the tangents, which is what's in like the darker purple, but now we're going to do the signs. So in the first quadrant, your tangent's going to stay positive. Second quadrant would be negative. Third quadrant would be positive again. Fourth quadrant would be negative again. So my advice is to do that much. On Monday, when I give you the blank unit circle, I would know enough to fill that out, okay? Because then you can use it on Tuesday. So when we get to questions like what's tan negative 1 of, what's cosine negative 1 of, what's sine negative 1 of, you've already done the work for it, okay? So I'm going to screenshot this and I'm going to bring it into the next example. These are, like we did with the bank of sine and cosine, it's the same for tangent, right? There's only so many questions you can get asked. Yes, oh, there's none in there. There's only so many questions you can get asked for tan, because you're limited from negative pi over 2 to positive pi over 2. Even further than that, the negative pi over 2 and positive pi over 2 are undefined. So you're not going to normally see like tan negative 1 of undefined, which means really we're going from negative pi over 3 to positive pi over 3. So if you could just learn those 7 values of tangent, then you can get to these answers. All right, all 3 are on this slide. So as a recap, sine, we're going from negative pi over 2 to positive pi over 2. Cosine, we're going from 0 to pi, and tan, we're going from negative pi over 2 to positive pi over 2, but we don't include those two because they would be negative, okay? Because they would be undefined, sorry. All right, so I'm going to bring in the thing we just filled out, which again, if you're smart and you know how to do on Monday, you'll already have it filled out. Oh.
Wait, what can you put on it?
You can put basically all the things I just went over. You could put all the angles, you could put all the trig values, you could put all the tangents. You could even label them like for your restriction, which one's which. Thank you. So everything you see there, you can put. You can add on your degrees. It's just that we don't typically, there's no degree questions in this section in 4-7. There could be from like 4, 4. If it said something like the cosine of theta equals, and it says give it to you in terms of degrees, those could use the degree symbol, but most of them use radians. All right, so if I find the exact value of root 3 over 3 and it's positive, I know I'm going to the over 6 in the first quadrant, which means this answer is pi over 6. Our tan of negative 1 is, where is tangent negative 1? So on my restricted domain of tangent, where would be negative 1? Negative pi over 4. And again, if you gave 7 pi over 4, it's wrong. It's not like you get partial credit. It's completely wrong. That's a coterminal angle, so it's in the same location, but it's the wrong answer for the inverse function. And then tan negative 1 of negative root 3 would be where? Good. Negative pi over 3. So we know, like, if you memorize your tangents, root 3 over 3, you should know that's an over 6. The negative 1, that's an over, or the 1, that's an over 4. The root 3, that's a 3. Now you got to figure out, am I taking it from the first quadrant, or am I taking it from the negative of the fourth quadrant? Because it's negative 1, for example, I go here, but I cannot use 7 pi over 4, I use negative pi over 4. And for negative root 3, I'm again in that fourth quadrant, but instead of giving 5 pi over 3, I have to give negative pi over 4. Carlos, you hand up.
Yeah, but I just couldn't see.
Okay. And you are going to get some calculator-based questions on your test. I think like the first 5 are calculator-based questions because right triangle trig, like your real world word problems, those were with a calculator, and then these, okay, are part of them. So I'm going to follow the bottom because we have graphing calculators, okay? If I wanted to find sine -1 of 1/4, what mode is my calculator supposed to be in? Radians. All inverse are answered in radians. So I'm going to make sure it's in radians, which will be a switch back and forth if I'm doing the real world trig stuff, right? If we talk about something at an angle of elevation, it's rarely in radians. So we'll have to make sure we pay attention. So I'm in radians, and I'm literally going to do sine -1 of 1 divided by 4. And I get, all right, so on the calculator, I do the next one, which was tan -1 of -9.65. And I get -1.467. It's 753. So that rounds to 75. Okay, think about restrictions on these kinds of questions. So if it had said something like sine -1 of 1.2, okay, what happens when you type that in your calculator? What's it say? Error, domain, right? Value entered is not allowed in the function or command. Think about what we're saying here. We're saying what angle has a sine of 1.2? Can sine be bigger than 1? No, because that's saying the opposite side is bigger than the hypotenuse. Can anything be bigger than a hypotenuse? No, okay? So sine and cosine can't be bigger than 1 or smaller than -1. Your calculator will yell at you. It will say error, but don't freak out. Know that that's what that means. All right, so this one says use a calculator, find the value, round to 4 decimal places. So I'm going to do second tan -5.2, and I get -1.3808. I'm going to do second cosine 0.2, 1.3694, and second sine 0.8. God bless you. 0.9273. Good on those? Okay. Those you have to be careful, make sure you're in the right mode. That's it. If you're in the wrong mode, you get a wrong answer, you have no idea. You put it down, you think you're really confident, you've lost all the points. Don't be that guy. Okay? All right. Example 5 says, use an inverse trig function to, actually, I'm going to skip this one for now. I'll come back. All right, we're going to actually skip this one because it's not on your test. Because this is a great SAT question. So use an inverse trig function to write theta as a function of x. So if theta is obviously in this right-hand corner and I'm given this side and this side, what two sides are those in respect to theta? Opposite and hypotenuse. So which trig function am I going to use? Sine. So the initial statement is the sine of theta equals the opposite side over the hypotenuse. What the question says is use an inverse trig function to write theta as a function of x. So I have to get it to just theta. How do I get rid of the sine of theta? What's the opposite of just sine? Or the inverse of just sine? Sine -1. You can either arc sine it or sine -1, but it would be sine -1 of sine theta would equal sine -1 of x plus 2 over 6. So sine -1 of sine theta becomes theta, and I would leave it in terms of the x. So I can't go any further with that because I have two unknowns. But what it wanted you to do was rewrite it as a function of x. So just like it would, like sometimes an equation will say write y as a function of x, it means solve for y. So you had to get rid of the sign. If it was adjacent and hypotenuse, it would have been cosine. If it's opposite and adjacent, it would be tan. Questions on anything we talked about today? So that's where your test content ends. Tomorrow I'll do the warm-up for, actually we could go back to it. All right, so these are your inverse properties, okay? And again, refreshers. So this is what I just said. Your sine and your cosine are restricted from -1 to +1. If I try to inverse cosine anything bigger than 1 or sine bigger than 1, it's going to give me an error. Anything less than 1, it's going to give me an error, okay? Tangent has no restriction on what we can find the inverse for. It could be positive, it could be negative, it could be huge, it could be anything, okay? Then on your restriction on your unit circle, so because this is going to apply again in a second, as a reminder, sine is restricted to -π/2, including -π/2 and +π/2. Tangent, same range, but you can't include -π/2 and +π/2 because they are undefined there. And then cosine is on the interval of 0 to pi, so we use the natural top part of our unit circle. Do is switch these. This on the outside needs to be the -1, and on the inside needs to be just sine. So -1 on the outside, and this is just sine on the inside. Okay, we need to switch those. So these are compound functions. There's going to be two functions. It could be a combination of both, like sine and tan. It could be sine -1 and tan -1. It could be any kind of any combination of inverse and regular trig functions. We work innermost parentheses first. So if I look at A and I start with sine of 5 pi over 6, what am I looking for? How do I find sine of an angle? The y coordinate at 5 pi over 6. If we went through the work on Monday and we filled out our unit circle, I'm literally locating 5 pi over 6, which is in my second quadrant. And the coordinate point is -√3 over 2 and 1/2. And I'm giving what as its sine? 1/2. So now I'm doing sine -1 of 1/2. Now what's it looking for? What does sine -1s look for? An angle or a value? What are you looking for when you do the inverse?
Angle.
The angle. So this is basically saying, tell me the angle where sine is 1/2. What's the answer to that?
5 over 6.
Now, there's the catch. Remember, sine -1 is restricted to the right-hand side. So I can only use the right-hand side, the negatives and the positives, to answer the inverse functions. I use the full unit circle to answer the regulars, but to find the inverse, I have to restrict it. So on the right-hand side of your graph, where is y 1/2? Good. Pi over 6. You with me so far? So think about how this changes if that was negative. Let's say it said sine -1 of 11 pi over 6. Actually, let's change this. Let's do this one. 7 pi over 6. Oh, I didn't write another sign. Sorry, hang on. Sine 7 pi over 6. So start innermost parentheses first. What is sine at 7 pi over 6? -1/2. What is sine -1 of -1/2? -pi over 6. Okay, it's the pi over 6 on the right-hand side of my graph, but it's restricted because it's got the -1s. All right, then we go to B, and it says sine of cosine -1 of 5 over 13. Is 5 over 13 on your unit circle? No. So if I don't have unit circle to use, what else have we used in this chapter with our trig functions? There's two ways to answer these questions, unit circle and Pythagorean theorem using right triangles. So I'm going to set up a triangle. I'm going to put theta in the corner. Great. Draw sine is what two sides? Adjacent and hypotenuse. So this would be 5 and this would be 13. I'm just going to keep flashing. What's the missing side of a 5 blank 13? Now what's the sine of that same angle? 12 over 13.
But what was the answer to the inside of the parentheses?
The inside, you actually won't be able to find theta. You're just using it to find the rest of the triangle, right? Because without a calculator, you can't do 5 over 13. All right, last one on this slide. So we're going to start inside parentheses first. Is 2√3 over 3 on your unit circle? No. So I set up a triangle. I put theta in the corner. Tan is what two sides? Opposite and adjacent. So opposite is 2√3. Adjacent is 3. This is not a triple, right? So I'm going to use the Pythagorean theorem. 3 squared plus 2√3 squared equals my hypotenuse squared. So I get 9 plus 4 times 3 equals x squared. 9 plus 12 is 21. And x equals the square root of 21. So now, what's cosine of that same angle?
Three square root of 21.
Go, okay. 3 over root 21, which becomes good. 3 root 21 over 21, which becomes root 21 over 7.